Key example numero uno for lesson 7-7. A population of rabbits in a lab can be modeled by the function blah, where x is the number of days since the study started. So if they're telling you that x is the number of days, then the 20 and the 1.034 do not mean the number of days. X means the number of days. Two very, very different things. And that P of X, that's the number of rabbits. So this whole piece is the number of rabbits. That's what this first sentence tells me. A population of rabbits in a lab, P of X. And then X being the number of days, that's what X is. Neither of those answer the question about what the 20 or the 1.034 are. So important to understand that. Remember, going back to our initial formula here, y equals that initial value. So the 20 is in the spot of the initial value. So that 20 is the initial value. What's this problem talking about, though? The initial value of rabbits in a lab. You know, X is the number of days since the study started, so it's the initial number of rabbits before the study has begun. So, let's go with blue. The 20 represents the initial number of rabbits when the study started. Important to realize, not day one, but day zero. Day zero number of rabbits. And again, the more detailed you can be here, the better and the more likely you are to get full credit. Using keywords like initial, started, that's really important also. Okay, so that one's not too bad, but the next part comes from picking apart that decimal, that 1.034. So as we talked about, that piece comes from the parentheses, which has the percentage within there. We can see immediately, because it is bigger than 1, that this is showing me growth. So we can see that the population of rabbits is growing each day. So let's phrase our sentence. The 1.034 represents the and so from that, we need to pull a percentage out of that, because that by itself is not just the percentage. So first off, taking that decimal, multiplying it by 100 to get the percentage of 103.4%. And now it's not increasing by 103.4%. The 100% represents that original amount. So we need to take that original amount out. We need to take that 100% out. Could get us left with that 3.4% increase. That's the key piece that you need to be able to do. So that 1.034 represents the 3.4% increase that the population, this is a little chunky on the words, or clunky, though, represents the 3.4% increase that the population of rabbits experiences each day. I'll go to a different one and read what I wrote for that one, because sometimes it's different depending on the day. Here it goes. The 1.034 represents the 3.4% that the population of rabbits is increasing by each day. Either way, what you're using it, it's really important to make sure that you have the each day and the percent that it's increasing by. Both of those things. We need to know how often that percent increase or decrease is happening. Okay, and this next part, this is just a review of stuff we've been talking about. Average rate of change. Hopefully you're committing this to memory, that average rate of change means change in y over change in x, which means right now we have time. So these are time values, which give me x values. So I need to find the y values that correspond with those x values. And I can do that by, again, using that formula that they gave me to start off with. And let's see, 21.034, close parentheses, caret to the 50. I don't know, got distracted. Perks of working at home. It does not tell me, it's like something's, I don't know, maybe someone's cooking, maybe my husband's cooking something, I don't know. Anywho, it doesn't tell us what to round to, so we're just going to round to the nearest whole number because that's what I want to do. So that's 106. And then we'll go back up, reuse that same one, and just change it to 100 instead, which was 566. Now that we have our x values, we can follow through with doing our change in y over our change in x. This, if I'm thinking about it, should be, I took from this one first, so 100 and then 50. This should be a situation of growth. It should be a positive average rate of change because the amounts, the rabbits are growing up. We have a percent increase going on here. Minus 106 is 460 over 50 divided by 50. And yeah, I guess it makes sense. Approximately 9.2. So what is the average rate of change from day 50 to day 100? Is approximately 9.2, which means approximately 9.2 change in y. The y value are rabbits. Per day is the approximation of what that basically means there.